Good morning, or good afternoon, or good evening, depending on where you are. So while you were waiting for me to join, you saw that my name is Mary Napolitano, and I am the product manager for LinacView. And this is some of my standard imaging family. And why do we come to work each day? It's because what if it were you or a member of your family with cancer? We are proud to be a leading manufacturer of radiation calibration and quality assurance instruments. We want to partner with you here at Standard Imaging. So a little housekeeping before we get started. Today's webinar is being recorded. And if you have to step away, if you're at the clinic and you're called away, you'll get a link later on so that you can review the rest of the session. Alternatively, if you're working from home and you're having internet issues, then again, you can review the webinar later. At any time, you can enter questions into the GoToMeeting dialog box, and I will address all of those questions at the end. Standard Imaging is based here in Middleton, Wisconsin, founded in 1989. We are a green company. We have geothermal heating as well as solar panels, which you can see in the picture. And we design and manufacture a full suite of QA products for radiation therapy. So the first thing I'm going to start with is what is the workflow like for LinacView, and what exactly is LinacView? So LinacView is software that one exports RT plans from the treatment planning system to. At the same time, those plans are exported to the linear accelerator. And then LinacView is always monitoring and waiting to receive log files from the Linac. So it's a log file based plan QA system. And so with this system, as LinacView is monitoring, when the log files come from the Linac, they are automatically associated with the RT plans exported from the treatment planning system. LinacView can be used for pre-treatment QA analysis, and then of course, and more commonly, and I think it's really most useful, well, equally, but extremely useful to do during treatment QA, comparing the log files to the RT plan, as well as that first reference log file analysis for each and every patient treatment. So every fraction, every day. And then as well, LinacView has templates that are internal that will produce audible or email alerts based on the tolerances that you have set up for your individual clinic. And then if it's one of those rare cases where you do get one of those email alerts, there are all kinds of tools that I will try to show you as we go forward. And then based on those tolerances, you'll get audible or email alerts as you have it set up. And you can receive both or either. And afterwards, if you have a case that you have received an alert on, and you want to investigate further, there are all kinds of tools, as I was saying previously, and then you can go ahead and you can export an RT plan and then feed that back into your treatment planning system to review the plan in a clinically meaningful way. So that's just the overall workflow of LinacView. And as I mentioned, there are detailed configuration options. There are custom templates to set your alerts and failures. You can monitor the jaws, carriages, monitor units, gantry, collimator, and table. You can do fluence map comparisons based on gamma, chi, and delta, analysis routines, plan complexity. You can review the modulation complexity score, even prior to receiving the log files. And so one is highly complex and 0 non-complex. There's the a combination of the leaf sequence variability, the aperture area variability, as well as different notification options that you can set up associated with these custom templates. There are also custom reports that are generated when the entire treatment is completed and you close it out. That's an option that is also automatically generated when you close out a session when your patient is completed with treatment. And then there are multiple RT plan generation options so that you can generate RT plans based on the total number of control points in the log files, and that can create some pretty large RT plans that may be very lengthy in computation time in your treatment planning system, or you can create RT plans using the same number of control points as the original RT plan, and there are even analysis mechanisms that can show you the expected variation between using every control point in the log file versus a limited number. And those are some good analysis tools there. And of course, we have numerous user rights options available from a very simple setup to the full admin. And so you can customize which users are granted which particular rights. One of the really convenient things about LinacView is that no user interaction is required unless you need to investigate further. So the log files are sent to a single instance of LinacView, which may be located in your dosimetry area, may be located in the treatment console. And then if it's located in an area where there are a number of people always present, you can have audible alerts set on your LinacView computer. And so that the people near the Linac then would hear the audible alert. Also, of course, there's always email alert, which is in some ways more common for the physicists, and then they can just head on over to the Linac if they get an email alert, or remote in if this software is installed elsewhere. And so you could have, multiple Linacs on your network, all getting monitored by your single instance of LinacView. The machine logs are compared to the RT plan prescription. And then I also wanted to point out that the log files, which are measurements of different mechanisms, real measurements of current or real measurements of mechanisms that are monitored by the Linac. So the log files are measurements of a sort, and they are acquired depending on your Linac vendor every 20, 50, or 250 milliseconds. And these parameters have an accuracy on their order of 0.01 monitor units, 0.01 millimeters, and 0.01 degrees based on the values in the log files. The Linac control systems, though, accept deviations in leaf position on the order of 2 millimeters, 2.5 millimeters, or 3 millimeters, depending on your particular Linac and model. And so with LinacView, we really have two types of QA that can be performed. The clinically relevant QA that I have been talking about up to this point, which is based on fluence comparisons. And so you would have your alert based on fluence comparisons between the RT plan and the log files. Also plan-specific monitor unit, gantry, collimator angles, beam off lags. And so you can have all of your alerts set on these clinically relevant parameters, and then alerts are sent. So in this case, you have immediate action to ensure that the treatment delivery is good, or if you have some sort of maintenance issue that's starting to occur that you need to investigate further. And so that kind of leads me into this second type of QA, which are the general machine performance parameters. So alerts aren't sent, and it's just meant for retrospective analysis and troubleshooting, and you can use it to predict future maintenance. Say if there is one plan in the morning that you're having issues with, and you just monitor it and make sure what's going on, and then it allows you potentially to go ahead and schedule your maintenance or take care of something during off hours, which is an important aspect for keeping the clinic running. So in addition, I wanted to bring up the fact that LinacView can create summary RT plans as well as individual RT plans for a particular log file session. So this particular treatment plan has 2 beams. It's exported from the treatment planning system, and then all fractions through fraction n, 1 through fraction n, are delivered, and the log files are analyzed within LinacView. And then an RT plan is created with 2 average beams based on all of the log files collected, and then you can export that and import it back into your treatment planning system. So that's another really nice tool to determine the clinical relevance of any issues that occurred in any of the fractions or the overall average plan delivery. And another key thing I would say that is really nice about being able to export the RT plan is that you can bring it back into your own treatment planning system. You have the same algorithm, you have the same beam model, and so you aren't looking at differences in, say, surface voxelization, or you aren't looking at differences, for example, in your beam model or the algorithm, which is really nice. So you can really focus on what are the clinically relevant differences that are being generated between what my plan is and what we have measured through the log files. So I have a few case studies that I have put together, and I'll go through those in the PowerPoint, and then afterwards, depending on how long the webinar is running, I'll launch the software and we'll go through a couple of those. And so the first case study that I bring up is, just your general prostate case. It's we have log files from the first 6 days of treatment. And one of the things I wanted to point out was the modulation complexity score. And so we have a value of 0.307, which is a pretty reasonable value, a good and easy plan for the LINAC to deliver is the point. So you could watch your modulation complexity scores, just kind of look at that after you have exported into LinacView. And then if a particular plan has a particularly low modulation complex score, then you can do the pre-treatment analysis and, get out your other measurement device if you would like to go ahead and check on some of these plans with an independent measurement device as well for plans that have a particularly complex delivery. But this one had a pretty straightforward and easy delivery. And I'm just showing here in this screenshot where you could go and see these values. And then I'm showing you on the batch dashboard that for these 6 sessions, they all passed. I was logged in admin mode because I think you've probably all noticed the failures here. And typically on the computer that's in the dosimetry area or in the treatment console, you're not logged in as the admin user. And so the users would only see the pass column. But this column that says all looks at the way I have mine set up. It looks at all of the parameters, each and every leaf. And so it's a much more restrictive review. The second case study I had is a head and neck. It's a single arc. The log file were generated on 5 different treatment days, and those are the ones that I had. And you can see in the batch dashboard again, 4 days passed and 1 day we had the alert. And this is in a different user login that doesn't have the complete analysis that I have in my admin account. And so you see the alert here on the 5th day. And so if you would go ahead and you can load this particular session, and you can load the session, and then you come to a summary dashboard. And what you see here is you see right up here at the top, of course, there's a summary, which is being shown here, some session options where you can look at the plan complexity based on the RT plan itself, dynamic views. You can review the JAWS, carriage, leaves, monitor units, the integrated log file versus the plan, fluence, the gantry, collimator, and beam off lags. And so what you can see is everything is color coded. And so things that pass are in green. So we can see that right away that an alert occurred with the gantry angle. And you can also see that down here in this summary page that I have the box around, that the maximum angle deviation has met or exceeded our alert tolerances. So all the alert tolerances are also specified here on the summary page, so that you can look and see how far you have exceeded any of these tolerances, and then your failures tolerance is in red, but these are just the tolerance values. And so over in this area then are the actual values. And you can see as well, we have summary for the collimator, monitor units, integrated fluence map comparison, and you can see the plan passed at 100%. So we need to investigate a bit further. So then one would click on the gantry tab, go in and look, and what I'm showing here in this screenshot on the left is what the gantry angle deviations were. And here you can see at the very beginning there was an alert because of a drive chain tension issue, which is very common on the older LINACs. And so that's just telling the physicist that, you know, he needs to keep an eye on this and perhaps do some adjustment at the end of the day. And so that's what one can see from this particular case. The next case study is another head and neck case, and it has a much lower modulation complexity score. In this case in particular, did have a fluence failure, so we would need to investigate further. And again, that came up. There was an audible and email alert. You can see that the failure occurs here in the composite fluence comparison tab. And you can see that we have a 95% pass rate, which is not what the clinic desires. And so one can go ahead and investigate a bit further. The next place to look is in the leaf settings. And so I've gone over to the leaf setting tab. And what one can see is that there, for many of the leaves, there is an RMS error that is greater than the alert level. And so what's happening is this is really a highly difficult plan for the LINAC to deliver. And what's happened here, you can see as well, this is focusing on leaf pair number 10, and you can go through and get this similar result very easily for every leaf pair and both banks. The purple is bank B and the olive is bank A. And what you can see is, it starts out near 1. 0 is the signifies that your log file leaf position exactly matches your RT plan leaf position. And so what you see is the variation, the leaf position deviation in millimeters between the RT plan and the LINAC log file. And so what you see is, it's going along. Bank number B is going outside of your alert limits. And then here around control point number around 155, 160, you can see there's an issue. But the LINAC, because it is designed to do so, does beam off during this period and allows the leaves to get back into position, and then beams on again. But you can go ahead and watch this in great detail in LinacView, the mechanism which is used. And so overall, the LINAC performed as it was designed. It, had a beam off for a period of time until the leaves caught up to the appropriate position. Case study number 4 is a breast plan. And this one actually had a failure in the beam off lags. So what happened is the leaves reached their maximum limits and continued to do so over and over again. But the other interesting thing that I would like to point out with this case, and perhaps we'll look at this one in greater detail later, is that the composite fluence really had a 99.1% pass rate. And so the composite fluence versus the dynamic comparison are much different, because over time, all of these dynamic differences did average out in the composite fluence. And so in this lower left side, I'm showing you the beam off lag failure. Again, this same dashboard page we were looking at before. You can see monitor units and the overall composite fluence pass, the gantry and the collimator pass, but the failure was in the beam off lag, which could also be seen from the initial batch dashboard. And so what's happening here is that all along the plan is being delivered, and then when these leaves get to the fail point, then the beam goes off as it should, and then when the leaves catch up, the beam the LINAC beams on again. And you can see that, it's on, off, but then the synchronization gets just a bit off in different locations. And you can see in the screenshot that I've shown, there is some additional information you can look at. So it's yellow up here in this area if the beam is on. So at this particular time, the beam is off. It shows you the gantry and the collimator positions, both of which are in green. But if those were out of your alert or fail tolerances that you have set, those would be an orange or a red also. And then the same with the monitor units, that flashes back and forth between the different colors as you look at the dynamic view as you play it in the software. So you can see some really interesting things going on when you review your log files in this mechanism. And the fifth case study I have is for an Elekta Unity prostate plan. This is an IMRT 15 beam plan. It has a modulation complexity score for the different beams between 0.24 and 0.48. And with the Elekta Unity mechanism of adaptive treatment, there is always a new plan each day. So we had to make some changes to LinacView in order to compensate for this sort of delivery mechanism. So with the plan of the day, you're not going to wait and close the plan at the end of the entire treatment session, because each plan is a different plan, and we need to compare those log files to the specific plan of the day that is generated via the adaptive workflow. And so, one of the things that we added, just so you can see what some of the options look like. So for a specific LINAC, the Unity at this particular location, you want to close every day. And I put in 11:15 in the evening, just before midnight, because by then, if you wanted to follow up with some measurement QA after hours, you could, and then the system closes the plan before patient treatment in the morning. Because we have these special considerations for the adaptive workflow, and there's no pre-treatment plan QA possible, because each plan is optimized and created while the patient is on the table, and each fraction is like a new plan. So the physicist is only able to measure after the patient treatment is complete. And of course, independent QA is desirable as it's a new workflow and new platform. And so in this upcoming release that should be out shortly, we have the plan closing in less than a day, and manual import and association of the RT plan after the log files have been picked up by LinacView just to support the case when the RT plan may not have been exported, or someone has forgotten to export the RT plan before the actual delivery occurred. And I show a few screenshots here. This is your 15 beams you're seeing. Again, I'm in this admin mode, so I can see a lot more parameters that I have set up in my templates. But typically they would just see these two alert cases. And then if we go and look at the summary, there's a slight difference in the monitor unit. There was an interrupt for these two beams. And then you can go in and you can review your details for your plan in as much detail as you want. So now I'm going to go ahead and see if I can get the software up. We're running kind of long, so I'll just keep it brief. But where I'm going to start is I'm going to start pretending like we have exported an RT plan to LinacView, and then also exported to the LINAC, and I'll just bring the log files in. And so the first thing you're seeing is a warning because I am not connected to a LINAC. So you will get a alert if you are not connected to a LINAC, which is a good thing. You always want to know if you're not collecting your log files. So that's a good thing to see. Let me see here. So what I have is I have my batch dashboard up, and then I have a LINAC simulator. And I'm going to go ahead and I'm going to put in a couple of those interesting plans that had some failures. So let's go ahead and put in the one with the beam lag. And if you listen, and let's go ahead and also put in this head and neck case. And what you're seeing, these two plans had failures, and you can cursor over the fail and get a nice quick summary of what the issue is. And with this one, it was that beam lag failure, and you could see that. And so we'll go ahead and load this session. And then you can see that the beam off lag is in red, which I already showed in the PowerPoint. But I'll go over here to the dynamic view, which is the interesting part to look at. And so what you're seeing here, I already showed you, and kind of keep your eye on this, is when the beam is actually on and off. And then I'll zoom in a little on this treatment area so we can get a better view. And then as well, watch the leaf positionings, and you can actually see the actual leaf deviation. In this one, it's 0.1 millimeter. And it's showing that bank A is a bit too closed, bank B is a little bit too open, but I'll go ahead and start the playing of the plan. And you can see when you're getting all of these leaves that are at alert and tolerance level, that the beam is going on and off. And the mean index is higher than one would expect, and when it's high, that's when the beam off lags are occurring. But you can see sometimes there is coloration in the fluence comparison map. When there's coloration, that means that we have fluence that is outside the plus or minus 1. And so those are the areas where we're really looking for. And in some cases, I can play it once more so you can look. In some cases, when that coloration is being shown, you can see the beam is on. So right now the beam's on, and you can see a good deal of coloration, but it's going on and off. So the mechanism isn't working quite as nicely as we would like as the plan is being delivered. So this is a really a complex plan, and it's not being delivered quite as we would have desired. And I'll go ahead and show you the other plan that we looked at briefly as well. You can see that there's some, there's a 95% pass rate, so it's a bit more than we would like, a bit more failure than we would like. And you can go back and you can look in the leaves area. And these are the screenshots I showed, but the other thing that you can see here are that you can just leaf right through all the leaves and take a look at all the leaves. And you can see where this around control point 155, 160 in there, that the beam did go off for a period of time, which you can see over here. There were no beam lag failures, but you can see that the beam is off during this entire area. And I think that is pretty much everything. Let me go back to the PowerPoint and for just a moment and close up. And so in summary, LinacView is real-time log file monitoring for every patient without impact on the patient workflow. The therapist can see dashboard results in real time during treatment. The physicists receive automatic email alerts for significant issues. There's automatic machine performance analysis for each fraction of every patient. So you're reviewing every plan as it's delivered. And it's easy IMRT BMAT QA using Fluence comparison. And so if you have any questions, please put them in the chat box, and I will take a look there in just a moment. And if you would like to get more information about LinacView, you can go to our website. Or for a more in-depth overview of the LinacView software, please contact your regional standard imaging representative. So now let me take a look in the chat box and see if there are any questions. I have a few questions concerning the cost and the cost per machine, and I will let that individual go ahead and contact their regional sales representative and let me know if you have any other questions. Please feel free to reach out to me as well. Again, my name is Mary Napolitano, and have a nice afternoon.